M means max and minimum problems. So these are specific as opposed to, you know, find the max, find the min. They're going to be kind of sneaky. All right? So that's what 4-6 is about. Let's see. Let's start with an example. If the sum of a first number squared and the second number is 27, what are the two numbers that form a maximum product? Okay. All right, there's a couple different things going on here, and we have to merge them. But let me kind of start with directions, kind of loose directions on how to do that. Okay, first step for optimization problem are to, if possible, draw a diagram, pick variables, that whole, like, what do I have, what am I looking for, just like you always do when you're doing a word problem. Okay, so we don't really have a diagram, but we're looking for two things, right? What are we looking for? What do you want to call them? X and Y, sure, why not? Okay, which one is the first, which one's the second? Okay, so this is our first number, and this is our second. All right, in that, so we pick that, we have a primary equation. I don't really like to start with a primary equation. We have a relationship. Find a relationship between your variables. Okay? So what would that be? I'm thinking it's the sum of the first number squared and the second number squared is 27. This is going to be an equation. Okay, some kind of formula sometimes will be applied. All right, so what's that? How would we write the sum of the first number squared and the second number is 27? X squared plus y equals 27. Okay, so we have that. All right, then we have a relationship. They call this primary relationship. That will give you the extreme value. I'll write the max or the min, because that's what these problems are all about. Okay, and they call it primary. I call it bottom line. What are we really looking for? We're looking for the max of what? Well, the two numbers that form a maximum product. So how would you write maximum product? Two numbers are X and Y. And what's the maximum product? You call it whatever you want. How do you say that? How would you write the product of X and Y? What does product mean? X times Y, okay? And that equals some product, what do you want to call it? E, okay? All right. Now, sometimes we call it max, because that reminds us, but the min would have an M, the max would have an M, so, you know, if you want to call M for maximum, that's fine too. You do whatever you want, but now we are going to merge those two things. Merge the primary and the secondary equations, or if you like this better, I know because they're not technically both equations, but write the primary, remember it's all about that, that's your bottom line, in terms of the other. Okay? So we are going to merge these, put this guy, this blue into red. All right, so how are we going to do that? What would be the easiest thing to do here? Do what? Set the blue equal to y. Okay, so what is y equal? Y equals 27 minus x, and then what would we do with that, Lauren? Yeah. Just check it. Okay, so we're going to have your x normal, and then y gets replaced with 27 minus x squared, and we have a merging. Okay, good job. So it's a substitution, but it's kind of weird because the p is like, wait, what is that p? Just p is our bottom line. Okay, now, remind yourself, where do we find the maximum and the min? Where do we always find the maximum min? They can be at the endpoints or the critical points of what? What do you think the next thing is to do? On the derivative, right? The derivative. So we can find the critical numbers. Okay. All right. So we need p prime. Oops, sorry. P prime. All right. P prime. What is it? I want to distribute that x first. All right, yeah, P prime, Ellie done? What? What's P? Okay, sounds good to me. Everybody not get that? Okay, now, where do you find the critical numbers? P prime equals 0 or P prime does not exist. Okay, P prime is 27 minus 3x squared equals 0. 3x squared equals 27. X squared equals 9. X equals what? Plus or minus 3. Okay, those are critical numbers. Okay, where does P prime does not exist? It always exists. Okay, where what are endpoints? Because this is a maximum. We're going to find P of 3, P of negative 3, and we need, those are critical numbers, we need an endpoint. What's the smallest number that x could be, or the largest number that x could be? Does it mention anything about we need positive numbers or? Okay, so there are none. There are no endpoints. Okay, that's pretty common in these applications not to have endpoints. Okay, x is 3. What's y? Remember, Lauren said y was 27 minus x squared. 27 minus x squared. So what's 27 minus 9. 18. So P of 3, so, okay, if X is negative 3, what's Y? Same thing, okay? All right, now the P of 3, remember, is, here's P. Okay, so, or you might have already gone to 27x minus x cubed. Okay, so what's the P of 3? What's the product of x and y? 3 times 18, what is that? 54. And what is the P of negative 3?
54.
What is it? Negative 54. Okay. All right, so we have all the information. Let's go back and make sure that we are writing down steps so we can follow them next time. Okay, we wrote the derivative so we can find the critical numbers, and then the max or the min, whatever one we're finding, will be found at the critical numbers or in points. Okay? All right. Of course, we just solved. I don't know that we need to write that because that's how you find the critical numbers. It's kind of assumed. Okay. All right. So let's make sure we answer the question. What are the two numbers that form a maximum product? You got two choices. We got, here's your products. Which one's the maximum product? Don't just circle. Answer the question. The two numbers are what? 3 and 18 that form the maximum product. Okay? We get kind of lazy and we're like, you know, it seems like the problem just went on and on and on and on. And then we're like, okay, we're finally done. But state what you were asked to state. Okay? So that's an easy one. I probably made it because I was trying to be very, you know, methodical. I probably made it a little bit more weird than it needed to be. Let's try another one. Yeah.
I'm
Sorry.
confused on when, I'm confused on when that x equals 3y, and did you just plug that into?
Well, that's the relationship between x and y, remember?
Okay.
Right here, you're finding x and y, so y is going to be 27 minus x squared. So yes, so we just plugged that x in to find my y, and then we took the product of the two numbers. Okay, any other questions? All right, let's try another one then. Okay, a farmer has 2,400 feet of fencing and wants to fence off a rectangular field that borders a river. He needs no fence along the river. What are the dimensions of the field that have the largest area? I have has here, but it seems like it should be half. Dimensions half, right?
Yeah.
Okay. Okay. Hmm?
That and 4 hours. Rectangle reveals that.
Borders
Okay.
without an S. Okay, so draw yourself a picture. A rectangular field that borders a river on one side. You're not going to put a fence. And identify your variables.
Should we assume that the two sides are equal?
Well, it's a rectangle. So that's assumed, yes. Where's your river? Okay. All right, identify some variables. Right now would be a good time where you get your figure on. Use LW, you can use X, Y, whatever you prefer. Okay, what about that? All right. So we have a river. You have a rectangle along the river. What did y'all use for abbreviations? Did you use L and W or X and Y? X and Y? Okay, did you use that for X? Okay. All right, if you didn't change it now, it'll just be able to make your life a lot easier right at the moment. Okay, so that's first step. Drawing a variable, drawing a picture, if that's appropriate, and picking out your variables. Okay. Now what? Figure out my relationship equation. What do I know? I got a number 2,400, and I got 2,400 feet of fencing then, right? Okay, so what does that look like with my x's and my y's? 2x plus y equals 2,400, okay? That's my secondary equation, but I like to find that first. It's secondary because it's not what I really want. That's just like what I know. Okay, so what do I really want? The primary equation. X times y equals A for area, okay? All right. It's a rectangle. You take length times width. Good job. Okay, now I'm going to merge these. I'll give you a minute. Go ahead and merge them. Be smart. Do the most efficient method here. Okay, got them merged. And you have 2,400x minus 2x squared? Awesome. Okay, now we got them merged. What's the next thing? Right, the derivative, so we can find the critical numbers. All right, what's the derivative, Catherine? 2,400 minus 4x, okay? All right, we're looking for critical numbers. So where critical numbers are where a prime equals 0 or a prime do not exist. Again, we're not going to have any of those, but it's just a good idea to keep it in your head, because then you stop thinking about it and then you forget about it, and that's going to be the time where that makes it in the. Okay, so what's your critical number here? 6,600. Okay. All right. So, okay, now basically the rest of the problem is, okay, let's figure out what is, we are looking for a maximum largest area. Okay. So, if we have one critical number, it's going to be a maximum, right? Do we have any endpoints? No. Well, 0, we don't really have, if x is 0, we don't really have a rectangle, right? Okay, and if x is 1,200, we don't have a rectangle because then we don't have y. So, again, X is not appropriate. That's going to give us our minimum, so this is going to give us our max, because that's the only critical number we have. So what do you want to do next after we have X? What do you want to do, Emma Bartlett? We're going to do find Y. Do you want to find A? What do you want to do? Find Y. That's always a good idea. So Y, remember, is right here. 2400 minus 2X. So 2400 minus 2 times 600. So Y is what? 1200. That's feet. That's feet. Okay, let's go back and answer the question because I think we're ready. What is the dimensions of the field that have the largest area? Dimensions with the largest area have to be what? 600 by 1200. If they ask you for the largest area, it didn't, but bonus. What is the largest area? 7, 2 with 1, 2, 3, 4 zeros. Is that what you said? Okay, square feet. Okay, good job. So sometimes they'll ask you for the, largest product, like the last one. Sometimes they just say, what are the X's and the Y's? So you got to watch, make sure you answer the question. Does anybody have any questions about the process? All right, I'm going to get rid of this then. I'm going to go to single page. All right. Okay, so this is find the parabola, point on the parabola. Y squared equals 2X. That is closest to the point 1, 4. Okay, very small written words, but all right, so we know this is a parabola. What kind of a parabola is that? Sideways, okay. So if you were graphing it, it would be looking like something like this. If you wanted to put in your calculator, y equals radical x into this part, y equals negative radical 2x, sorry, would be that part. Okay? If you really want to look at it. Okay. Now, where would be, let me try that again. Where would be 1, 4? Is it on the parabola or not? No. Okay. So 1, 4. What's that point and that point? 1 what? Radical 2. So it's radical 2 is 1. So let's say it's about right here. Here's my point 1, 4. Okay. And I want closest. That's my extreme word. What does that mean? A minimum or maximum? Minimum. What are we looking for then? Minimum what? Distance from 1, 4 to the parabola. Okay. So let's just say it's that right there. Okay, I don't know what that is, but I do know it has an X and a, bless you, it has an X and Y on it. Okay, and I know it's probably perpendicular at that point to the curve, because that's the shortest distance between 2 points. All right, so how do I find the distance between 1, 4 and X, Y? What? Okay, Emma, you're talking about the distance formula, I'm thinking? All right, go for it. What is it? Which is? Okay. Good job. All right, so the distance is going to be that square root. Now, if I have, oh, never mind, I won't go there yet. I got a lot going on here, and this would be considered our primary, right? That's really our bottom line, to find the smallest distance. What's our secondary? What's this? Isn't that an equation? That's our secondary equation. Y squared equals 2x. Okay. Don't forget about the stuff they give you. They're not giving it to you for just for fun. Okay. How are we going to merge those? What? Put the secondary into the primary, correct? How do we want to put it in there, Kate? No, you can go from x. What's x? Yeah, you can do whatever you want. That's the most efficient way. Okay, so my distance is y squared over 2 minus 1 squared plus y minus 4 squared. Okay, that's a mess. All right. Any suggestions about what kind of algebra we're going to have to do from here? I heard it over there. Boyle. Okay. Emma's on it today. All right. Ellie Crawford, Boyle me this, please.
First one?
Yeah.
Okay. Y squared 4 over 4 minus 2y squared over, no, just 2y. Just
y squared?
Yeah.
Okay.
Plus 1.
Good job. All right. Rachel, form me the other one.
Plus y squared minus 8y plus 16.
Okay. That's a lot easier, wasn't it? Good job. Okay. Good job on that, Ellie. All right. Okay. Now here's the question I was going to ask earlier, and I thought, well, all right. So let's say we have 2 points. The 10. Okay, but let's talk about distance. So let's say this is square root of 15, and this distance is 5. Okay? Now, clearly this is the smaller distance, correct? All right, what's the square root of this? 25, right? So square root of 25 is bigger than the square root of 15, right? So can we just ignore the radical because the square of the distance is going to be the smaller one too, right? So we're just going to deal with d squared, but we're going to just call it something else. We're going to call it m. Okay? So because if the root is the smaller one, so is the square. So that's all we want is the smaller one. We know to find the distance, we're going to have to take the root, but does that make sense? Okay.
Can you explain the first one? Like,
Well, if you got 2 distances and one is, and they're both roots, you can actually look at the number underneath the root and tell which one's bigger and smaller, right? You don't have to look at the actual square root, right? So that's what we're doing. We're just not looking at the square root. We're just looking at the number underneath. So we got rid of our y squared. What do we got left here? Y to the 4th over 4
minus 8
plus 17. Okay. All right. Now, that's our merged. Don't forget where you're going here. What's next?
Derivative. Let's do that first. Okay, because sometimes all this is so involved that we're like, we forget the derivative. I think, Emma, didn't you talk about that last time when you were like, when we were doing the absolute max, you were setting the max, the f of x equal to 0 to the f prime. Okay, so what's this? 1/4 4y cubed, which is really y cubed, minus 8. Okay, so that's a decent, I think if we had to do the chain rule and all that. Okay, so y cubed minus 8 is my derivative of my distance, technically distance squared, but it doesn't matter. Okay, so where does the derivative equal 0? Y cubed equals 8. What's y? 2. Okay, so what do you call this? What do you call this? Critical number. Good. Okay, so that's a critical number. That's the only place that a max or a minimum can occur, unless there's some endpoints. Are there any endpoints? I mean, we're looking for minimum, so it's got to occur at 2, right? Okay, so it occurs at y equals 2. All right, so occurs at y equals 2. All right, so now what? How do I get x? Okay, or y equals 2x, because we know theoretically that it could be this one or this one, but really if we're closest, we're going to be closest to this guy instead of this dude here, right? Okay, so when we plug in a 2 there, what does that become? What does x become? Oh wait, we're plugging in 2 into y, right? 2 equals 4 equals 2x. X is also 2, right? All right. So the minimum distance by the point on the parabola, I think we just found it, that is closest to the point 1,4, it is 2. Okay. So just to be clear, the point that is closest to 1,4 on the parabola is 2. No, it doesn't really matter because that's how we found the critical number. So yeah, I mean, it would have worked out the same and just been a lot more headache to find the actual derivative with that square root and all that business. Yeah. So, width, so that's what? 21.5 minus 2x. Okay, and what's your height? X, because that's the folded up part. Okay. Oh, yikes. It had to be 21.5, right? I'm going to multiply my x by this guy and then FOIL. Trying to do this efficiently, so let's 28 times 21. 602 x minus 42x squared plus 4x cubed. What am I missing? I didn't do FOIL, so minus 54x, 56x. Yeah. That's what happens when I try to use mental math. I'm not so skilled in that area. Okay. I think that's right. Okay. All right. That's volume. It's already kind of, there's one situation where we really don't have a secondary because we already kind of figured out every the things in terms of the x already. So it's kind of already been merged. So there's no merging of any primary and secondary. It's already done. Okay, so what's the next thing to do? Derivative. Will be prime. All right, so that is 602 minus 86x plus 12x squared minus 56. is it? Did I,
28 times.
okay, so that's 112, is that right? X, okay. If I really was doing this better, I would have rearranged so I could FOIL quicker than that, but, all right, so 12x squared, I got 86 and 112. 198 x plus 602. Okay. All right. Here's your, huh? Jeez, 198 is what I said, and then I didn't write that. Okay, thank you for listening to me because I'm not clearly, I'm trying to rush. Can you tell? All right, okay, go ahead and solve that using your program. Your program, your quadratic formula program. Oh, that sucks for you. Okay, I need the decimals because clearly we want to see who's the closest here. So x equals, I got 12.48.
That's what I got.
Now, and 4.020. Okay, now, this one's not a reasonable answer, is it? Because if you take 12 from both sides here, you have less than 21 and a half left. So this is not reasonable, and that happens. Okay. And you would find that if you didn't even figure that out, once you start putting it in here, one of these blanks, and you know, it's going to be negative. There's no such thing as a negative blank, right? Okay, so our 4.2, that's why Emma got the biggest. Go Emma. All right. So then we would have to plug that 4.020 right there. Maximum value. You write it down.
Oh, it's my job. The bell rang. I was going to
No.
That you can.